All right, welcome. We're going to do some exercises in 101G, the alignment ILM. First one, objective one, exercise one, looks like we're going to be working on a 2009 Toyota Prius. Excellent. We're going to be conscious of the environment while we talk about alignments here. And here we go. So what the first chart's asking there for is just for us to write down the range of the working angles. Um, Nominal meaning exactly on specification right in the middle, and then the range, which gives you your minimum and maximum, is going to be the plus minus section. So if we were to look at front camber, nominal, I guess I better get set to the proper pen. There we go. Our nominal will be 0.6 degrees, and plus or minus 0.75 will give us negative 0.15, and plus 0.6 is 1.35 degrees. Probably not going to write the degrees every time. That's all right. Anyways, and then we're just going to carry on doing that for the rest of the chart. So I'll just write down the nominals quick. 3.2, 0.1, negative 1.5, and 0.30 degrees, or 0.3. And then we look at our range. For front caster, we have a range of 0.75, giving us 2.45 to 3.95. Total front toe is 0.1 plus or minus 0.2, giving us negative 0.1 to a positive 0.3 degrees. Keep in mind, this is total front toe, meaning it's the right side and the left side added together. And toes frequently listed as total because if you just list it as left and right, well, guess what? The steering wheel turns. So as you turn the tires, one end would go more positive, one end would go more negative. The difference between the two, as long as you're relatively straight, should be 0.1 according to them. So when we look at the angles later, we're going to want to see 0.05 left and 0.05 right. Rear camber, negative 1.5 plus or minus 0.5. So we have negative 1.5 minus 0.5 is negative 2. And at the high end, when you add 0.5, you're going to be at negative 1. So we're going to want to see that. And again, that's 2.00 and 1.00. We got to remain accurate. Total rear toe should be 0.3 degrees plus or minus 0.25. So minimum is 0.05 and maximum is 0.55 degrees. So we have this vehicle, we've observed the specifications, what they want to do. We're going to see what's going on. We drive the car, we bring it onto the alignment rack, and here's the readings we get. So let's have a look. I better keep the specs so I can see them. Let's have a look at these. Now, first thing, remember when you're looking at alignment angles and doing your adjustments, you're going to want to look at caster camber in the rear first, and then set your rear toe, and then move up to the front and do your caster camber toe again from the front. So front toe should be the final measurement that you're taking and looking at and adjusting. So in this case, we'll look at the rear camber. We have left at negative 1 degree, right at negative 1.1 degree. And although that's at the high end of spec, so remember the rear camber spec shows the maximum of negative 1.0, and we're right on that with the left, and then with the right it's only 0.1 degree lowers or closer to nominal. And so in that case, yes, we're in spec. The cross camber between the left and the right is only 0.1 of a degree off. When you're correcting for road crown, you never want to do it with rear camber. You want them to be as close to nominal as possible. But in this case, they're both within specification. I think that one's okay. Good to go. Ignore it. Rear toe, 0.7 degrees. Whoo, way die. That's high. 0.7 degrees on left, 0.7 degrees on right, and that gives us a total rear toe of 1.4. If you look at the specifications here, nominal is 0.3 degrees. So we are 1.1 degrees off of where our toe should be sitting. And in this case, those guys really need to be brought down lower, and we want to get them closer to 0.15 on the left and 0.15 on the right. So those guys are bad. And the other thing I say, if you've got a lot of toe, so I'm going to draw this really exaggerated, you got a lot of toe, whether it's on the front or the rear, and you're driving down the road that direction, the tire is going to want to kind of curl under itself as you drive, and it'll constantly want to curl under itself, causing kind of a sideways feathering wear on the tires. And you're going to be able to see that, but you're also going to be able to feel it with your hand. And if you rub your hand, crossways across the treads, you're kind of going to have that pattern. If you rub your hand in that direction, you're going to find that it's smooth, and you rub your hand in the other direction, you're going to feel all those sharp edges of the treads, and it'll feel sharp. So it'll be smooth one direction and sharp the other direction, and that'll give you the tire wear indications that you're looking for when you have a toe problem. This is definitely excessive rear toe, so that's got to be adjusted. That's going to cause tire wear, hands down for sure, but both the left side and the right side are the same amount. And if the left toe and the left rear toe and the right rear toe have the same on both sides, that tells me that my thrust line is good. So my thrust line is good. It's in line with the geometric center line. Perfect. It's dead on zero. I'm happy with that. Now we move to the front. We're going to look at the front camber. And here I see that the front camber has huge 1.4 degrees on the left side, 0.75 degrees on the right side. Now, the specification of 0.6 degrees, and that tells me right now that when I look at the right side at 0.75, I'm not too bothered by that. It's slightly above specification, but only by 0.15 of a degree. I'd live with that and carry on. Where I'm really concerned is my left side of camber. That 1.4 is definitely excessive. That's going to be a problem. That guy needs to be brought down. And I'd bring that one down to specification. We'll talk about where we would set it for the different rules, but should be closer to where that right side is at 0.75, maybe up to 0.8 or 0.9, but keep it within spec. That's also going to cause some tire wear on the outer edge of your left front tire. So if these are your tires, this will cause some tire wear from the camber just along that edge there, and it won't be that feathering type of wear. It'll just be a smooth wear just from the tire riding on that edge a little more frequently. More pressure on that tire, I should say, on that corner. Then our front caster, we've got some readings of 3.85 degrees left and 4.4 degrees right. We're looking for 3.2 degrees as for nominal. So the left side is at the high end of caster, but still okay. The right-hand side is considerably higher than specification. You'd want to bring that guy down. The other thing I notice, if we remember, is a pull. So camber will pull towards the most positive side. Caster will pull towards the most negative side. In this case here, we have a front camber That's 0.65 of a degree, and it's higher on the left, meaning that's going to be a 0.65 degree pull to the left. And then caster will pull towards the more negative side. It also has a swing of I was going to say 0.65, it's actually 0.55, but it's lower on the left. So you're going to have a 0.55 degree pull to the left. This guy's definitely going to have a pull to the left. Both camber and caster are pulling to the left, and by considerably more than you would normally set to compensate for road crown. Again, using my units of pull, generally I say that camber has a 0.25 degree unit of pull. Caster is a half degree or a 0.5 degree unit of pull. So if I was to look at this when I'm adjusting or setting for road crown, I normally want to have between 1 and 2 units of pull to the left, and that'll compensate really well for road crown. In this case, we have a little more than 1 unit of pull for caster, and then we have a little more than 2 units of pull. Sorry for the screen jumping. All right, we have a little more than 2 units of pull for camber, meaning this guy is going to have a pull to the left. It does have 3 units of pull or more than that heading to the left-hand side, so you're going to end up with some issues there. Finally, the front toe. Again, they want a total of 0.1 degrees, which is 0.05 on each side. The maximum should be set to 0.3, which is 0.15 on each side. And the front toe, left and right, are both 0.1 degree higher than what the maximum should be. So you'd want to drop that toe down to correct the toe on each side. And you'd probably want to lower each side the exact same amount, seeing that both left and right are at that 0.25. It's possible that a little bit higher front toe could cause a little bit of tire wear on both the front tires as well. Probably won't be as excessive as the camber wear. And so when we look at what could happen, circle all that apply for customer complaints. Well, they're definitely going to see rear tire wear. That toe in the rear is horrendous. So it's way too high. You're going to see rear tire wear for sure. The other thing for sure, we got a huge pull to the left. So this guy will pull left. Doesn't matter how you look at it. Definitely a problem going along that lines. And then when we look at the other stuff, because it is pulling left, I would also suspect that the steering wheel may be complained about being off center, but it's off center because you're holding it off center to the right to try to compensate for the vehicle wanting to go left. Then your tire wear, your left front tire is going to show some toe wear, very minimal, but some toe wear, and then some camber wear. You're probably going to see some left front tire wear. The right front tire is going to be seeing a little bit of toe wear, and the camber is well within specifications. So the right front tire, no guarantee, but I just say maybe you would see a little bit of wear. I doubt a customer would ever complain about it. And that's only because of the 0.1 degree of toe that it's off. So chances are they wouldn't say anything about that. Moving on, using the specifications, fill in the rear camber settings. And rear camber specification was negative 1.5 degrees. You never want to correct or compensate for road crown using the rear. And go through this, set the rear to as close to specs as possible. So in this case, we're going to hammer off a very simple negative 1.5, negative 1.5. So there's our rear camber. And then it says, using specifications, fill in the rear toe settings on table 8. Again, total toe that they're asking for is 0.3 degrees. You want to get it as close to that as possible. So what we're going to try to set this one to is 0.15 per side. Remember, because the left and the right toe add up to give you total toe. All right, and it says using nominal rule, fill in the settings for table 9. So the nominal rule is essentially you take your nominal specification or your center dead on recommended specification, and you're going to add 0.25 camber to the left, or you're going to add 0.25 caster to the right. So you'll have essentially a 1/4 degree camber pull to the left, a 1/4 degree caster pull to the left, getting you into about that 1.5 units of pull to the left. Works out really well, and it uses both camber and caster to adjust for road crown. So in this case, I'll just write the specs down. Front camber would be 0.6 degrees, front caster was 3.2 degrees, and by using the nominal rule, I'm simply going to add 0.25 to set the right. So I'd be looking to get my left front camber to 0.85, and then I'm going to add 0.25 caster to the right for 3.45, and there's the nominal rule. Again, just reinforcing, that's giving you 0.25 degrees pull to the left of camber and 0.25 degrees pull to the left for caster as well, because caster pulls more negative. Using the equal camber rule, fill in settings for table 10. So equal camber rule means we're going to set camber equal. So if we're setting camber equal, we want to be dead on specifications, and we're going to do 0.6 degrees on each side. Then for caster, we're going to take nominal, and we have to do a little more adjustment. So we're going to take nominal, and then we want to do minus 0.2 on the left and plus 0.2 on the right, giving us 1/2 degree pull caster. So again, our nominal is 3.2. So if we take away 0.25, that gives us 2.95 on the left, and add 0.25 to 3.2, giving us 3.45 degrees on the right, and the road crown compensation would be 0.5 degrees pull caster to the left. If I'm working on a vehicle that has caster adjustable, I'm going to be following this rule. Set the caster at least 1/2 degree, maybe even a little more, 0.5, 0.6, 0.7 lower on the left-hand side. If caster is adjustable, this is the best way to compensate for road crown, because caster is not necessarily a tire wearing angle, and it gives you more straight ahead ability. So it's better for highway driving and returning of the steering wheel. If caster is not adjustable, of course, we're left for using the equal caster rule. And the equal caster rule essentially means caster is what it is. 3.2 degrees is where you'd want it. If your caster is way off from that, there might be some damage or something bent or something along those lines, if caster is non-adjustable. And then your camber, you want to be adjusting for road crown using your camber. Same theory, take the nominal measurement of 0.6 degrees, add 0.25 to the left, and take away 0.25 to the right, giving us 0.85 and 0.35. So that would be a 0.5 degree pull of camber to the left-hand side to compensate for road crown. So that's using equal caster. And then using specifications, fill in for the toe setting. Well, don't mess around with that. It wants 0.1 degrees total toe. So we're going to set each side to 0.05. There you go. Keep them going straight down the road.